In the last several lessons, we've examined in detail the features of the SN1 reaction and the SN2 reaction. For many problems, although not all, you will need to decide whether a particular reaction goes via the SN1 mechanism or the SN2 mechanism. So in this lesson, I put together on one slide a summary table of when you would expect SN1 and when you would expect SN2 based on certain features of the reaction. So the first thing you should look at when you see a nucleophilic substitution reaction is the structure of the alkyl halide. If it's tertiary or resonance stabilized, preferably resonance stabilized secondary, then it's in the game to undergo the SN1 reaction. If it's methyl, primary, or small secondary, then it will undergo an SN2 reaction. The second thing you should look at is the quality of your nucleophile. If you need to, go back to the lesson on nucleophiles and internalize which sorts of nucleophiles would receive an A, which sorts of nucleophiles would receive a B, which sort of nucleophiles would receive a C. For the SN1 reaction, it doesn't matter how good the nucleophile is. Anything with a lone pair can be a nucleophile in an SN1 reaction. For the SN2 reaction, we need an A or B nucleophile, one of the better ones, because as you recall, the nucleophile also has to engage in the process of kicking out the leaving group. Next thing you should look at is the solvent that's given to you in the reaction. For the SN1 reaction to take place, the solvent must be a very polar solvent. Water, methanol, some combination of water and ethanol. For the SN2 reaction, polar solvents help, but they are not crucial. So SN2 reactions can go in a wide variety of solvents, including solvents that have been classified as moderately polar solvents, back in the lesson on solvents. Then finally, if you have a chiral alkyl halide, you have to consider the stereochemistry. If you have determined that the reaction is an SN1 reaction with a chiral alkyl halide, you will get a racemic mixture of enantiomers. However, if you have determined that the reaction is an SN2 reaction, you will get one enantiomer of product in which you have inversion of configuration at the stereocenter. So if in the starting material you had a wedge, the leaving group had a wedge at the stereocenter, in the product, the nucleophile that comes in must have a dash. In the next lesson, we will talk about how to approach, in a systematic manner, predict the products problems, which are one of the common types of problems you'll need to solve in this unit.